Welcome to Mastering Solutions. For this question, it's really helpful to draw a picture so you can conceptualize what's going on. It's really confusing with all the different materials that they've given us here. So of course they say that we have this oil and it's sandwiched between the two mediums. This top one we're going to say is the glass. And then we have the oil in the middle and then the polystyrene plastic on the bottom. And we want to figure out how long it's going to take for the incident light to go through all of this sandwich that they gave us. And so it's really just a continuation of the last two problems that we've done, where we're using the velocity equation, which obviously is the change in distance over change in time. And then we're just going to rearrange that and then use it to solve for how long it took to go through all these different things. We just have to do it several different times, then we'll add them together. We know, as we've done in the past few problems, that the velocity of light through a certain medium is going to be equal to the speed of light in a vacuum divided by the index of refraction. And so we're going to use that to plug it in over here. So if we rearrange the velocity for time, that will give us the change in time is going to be equal to the change in the distance over the velocity. And then we can plug in the velocity to it. So we have the change in time is equal to the change in the distance divided by c over n. And then this is what we're going to use several times to figure out all these different ones. Let's add the index of refractions on these just so we get them straight. So they say that the index of refraction for the oil, n, is going to be 1.46. The index of refraction for the plastic is 1.59. And we know, of course, that glass is 1.50 index of refraction. And then they say the different thicknesses. The glass is a 1 centimeter thick. So we have 1 centimeter, which is equal to 0.01 meters. And of course, you could do 1 times 10 to the negative 2 meters, same thing. And then we have the oil is 5 centimeters. I guess I drew this a little weird. The oil should actually be quite a bit thicker. So we have 0.05 meters. And then the plastic is 2 centimeters. So we have 0.02 meters. Okay, so now we have all of our variables in our equation and everything. Now we just have to plug everything in. So let's start off on the glass. So the glass is going to be equal to time is the distance. So we have 0.01 meters. We're going to divide that by 3 times 10 to the 8 meters. That's divided by the index of refraction is 1.5. And then let's go to the calculator. So we have 0.01 divided by 3 times 10 to the 8th divided by the index of refraction. We have 1.5. So the time that it took in the glass was 5 times 10 to the negative 11. And so if we move the decimal place over 2, that's going to give us 0.05 times 10 to the negative 9, or 0.05 times 10 to the negative 9 seconds, which is the same thing as saying 0.05 nanoseconds. So I just moved it from the negative 11 just so we had it in a unit that we're more familiar with. Now I can do the same thing with the oil. So let's go with the oil, and we have the time is equal to the distance. So 0.05 meters divided by c over the index of refraction we said is 1.46. So we have 0.05 divided by 3 times 10 to the 8th divided by 1.46. So we have 2.43 times 10. So if we move it 1, that'll give us nanoseconds. So we have 0.24 nanoseconds. And then lastly, we have the plastic, of course. So T is equal to 0.02 meters divided by C over that index of refraction they said was 1.59. And then one more time, we have 0.02 divided by 3 times 10 to the 8th divided by 1.59. Okay, and that gives us 1.06 times 10 to the negative 10. So let's do the same thing. We have 0.106 nanoseconds. There we are. Okay, so now they wanted to figure out what is the total time that it took to go through all of that, right? So we just have to add them up. So we have time total is going to be equal to the time in the glass plus the time in the oil plus the time in the plastic. So we have 0.05 nanoseconds plus 0.24 nanoseconds plus 0.106 nanoseconds. And so we kept the units very consistent so that when we go to add them up, we're not having to worry about the scientific notation and keeping them all the same. So we have 0.05 plus 0.24 plus 0.106. That gives us 0.396. So we could round that. So we have the total time, T total, is equal to 0.40 nanoseconds.